Good morning, students. Once again, I welcome you all for this session. Okay, so we're going to solve one more important problem. Then we're going to see the second type of problem. So the problem is like this: rectangular section of effective size. See here it is mentioned effective size. Effective size 300 mm into 500 mm is used as a simply supported beam for effective span of 7 meter. Okay, so effective size means B into small d effective depth. Okay, right. What maximum UDL can be allowed on the beam if the maximum percentage of steel is provided only on tension side? Okay, this is important now. Okay, what maximum UDL, that is small w, we are going to calculate. What maximum UDL can be allowed on the beam? Condition is if the maximum percentage of steel is provided. So steel provided will be maximum, means it is more than the limiting condition, provided only on the tension side. Use M20 concrete and Fe 415 grade steel, and you have to also determine the amount of steel to be provided. Okay, so I have written here, it is important, so please note that as per your exam point of view, this is important. So try to understand the problem. Okay, so rectangular beam of effective size B 300 mm, and effective size means it is small d only, effective depth 500 mm, is used as a simply supported beam for effective span of 7 meter. So span of the beam or length of the beam will be 7 meter. Okay, then condition is what maximum UDL can be allowed, means you have to find out small d. Okay, that is UDL can be allowed on the beam if the maximum percentage of steel is provided. So condition is the maximum percentage of steel is provided on tension side, means here bottom. So what it indicates? So the steel provided will be maximum. Okay, so when it is maximum, when you provide steel maximum, what happens? The above condition indicates that the beam is over reinforced. Okay, when you provide more than what is required, then the beam will be over reinforced section, and you know that over reinforced sections are not allowed and design is restricted to limiting condition. Okay, so you have to consider that this condition is limiting condition. Okay, so that is the important point you have to remember here. So maximum percentage of steel provided means it is a limiting condition, means it is over reinforced, and since over reinforced sections are not allowed, right, our beam is restricted to limiting condition. Okay, so as usual, okay, use M20 concrete, means FCK is 20 Newton per mm square, and steel is Fe415 grade, then it is Fy is equal to 415 grade steel. And you have to also determine the amount of steel to be provided. We don't know how much steel required, but it is given that maximum steel is provided. Okay, so but how much it is, we have to calculate. So we need to find out two things here. One is total UDL, okay, and second one is area of this steel. Okay, so according to the condition, okay, so the beam is restricted to limiting condition. So what is limiting condition? So at limiting condition, xu by d or xu, okay, so actual neutral axis depth xu is equal to maximum neutral axis depth or limiting depth of neutral axis xu max, or you can say that xu by d is equal to xu max upon d for this condition. Okay, xu by d is equal to xu max upon d, and we know that what is xu max upon d for Fe415 grade steel. So xu max upon d is equal to 0.48 for this Fe415 grade steel. So xu max upon d is equal to 0.48, or even xu by d is also 0.48. Okay, now this is at limiting condition, xu by d is equal to xu max upon d. Then what about mu? So at limiting condition, mu will going to becomes mu limit. Okay, xu is becomes xu max or xu limit, and mu will going to become mu limit or mu max, m max. Okay, so therefore you can write ultimate moment of resistance. Okay, mu limit or mu only it is. Ultimate moment of resistance mu limit is equal to, again for Fe415 grade steel, what is mu limit? 0.138 FCK BD square. Okay, for this Fe415 grade steel, mu limit is equal to 0.138 FCK BD square. So substitute the values. 0.138 FCK is 20, B is 300, and effective depth is 500. Okay, so substitute, you will going to get mu limit is equal to 207 into 10 to the power of 6 Newton mm. Okay, it is 10 to the power of 6 Newton mm. If you want to convert this Newton to kilonewton, divided by 1000 or 10 to the power of 3, then millimeter to meter, again divided by 10 to the power of 3. So total you can divide this by 10 to the power of 6, and this 10 to the power of 6 and bottom 10 to the power of 6 get cancels and remains 207 kilonewton meter. This is 10 to the power of 6 Newton mm, and this is kilonewton meter. So this is the ultimate moment of resistance. Okay, mu limit. Now for finding out this UDL, we can convert this mu limit or mu into working moment. So working moment of resistance, okay, working moment of resistance m, this is mu or mu limit. So how will calculate m? M is equal to, or working moment is equal to, this 207 divided by 1.5. Okay, 207 divided by factor of safety, that is 1 point factor 1.5, will get 138 kilonewton meter. This is ultimate moment, this is working moment. Working moment means m. So working moment of resistance given by the beam will be how much? 138 kilonewton meter. So this is the first quantity we have found out, but we need to find out the total UDL. Okay, so now what is total UDL? How are we going to find out? So UDL will be denoted as small w. Now see, this is a simply supported beam, okay, resting on two supports, and span will be 7 meter, and it is subjected to UDL. So this UDL includes what? This is a total UDL which will be including self weight of this beam plus live load. Live load plus self weight of the beam will be acting in the form of UDL, that is W, small w per meter. Now for this condition, simply supported beam, okay, subjected to UDL, we have to find out what is the maximum bending moment. How much bending moment will be coming on this beam? So for simply supported beam carrying UDL, maximum bending moment is given by, so that is M max is equal to what? WL square by 8. For simply supported beam carrying UDL, it is WL square by 8. So where the maximum bending moment? At the center. Okay, so this is WL square by 8. So keep W as it is. So 7 square, that is 49 divided by 8 into W. So this M max is what? This is a total bending moment. Okay, this is a total bending moment coming on the beam because of this UDL. So and then who will going to resist this? This bending moment will be resisted by this moment of resistance M. So these two must be same, because moment of bending moment will be this much, and same resistance will be, they should be there, and the moment of resistance is 138. Okay, so this moment of resistance will be equated to this maximum bending moment. So equating maximum bending moment this to the moment of resistance M. Okay, so M max, this is M max is equal to moment of resistance M. So M max is 49 divided by 8 into W, that is equal to moment of resistance M, working moment of resistance, this is 138 kilonewton meter. Okay, so 138 kilonewton meter. So therefore W is equal to what? 8 into 138 divided by 49. So total UDL, okay, total UDL will be 22.53 kilonewton per meter. Means this UDL, the intensity of this UDL will be how much? 22.53 kilonewton per meter. Means for 1 meter, okay, per meter means for 1 meter, how much the load? It is 22.53 kilonewton. So this is the total load, okay, total UDL which is coming on the beam. So W is equal to 22.53 kilonewton per meter, which includes live load plus self weight of the beam. Including both, it is 22.53 kilonewton per meter. So this is the first quantity they have asked, and we have found out total UDL. Second quantity they have asked amount of steel to be provided. So how much of steel, okay, required for this here? They have mentioned maximum percentage of steel is provided. Okay, so how much steel we are going to calculate? That is area of steel. So for this, what we are going to do here is we are going to equate the total compressive force to the total tensile force. In the beginning class, we have seen there will be two forces. Okay, one which is there in the concrete and another force which is there in the steel. So the total force in concrete is C, capital C, and total force in steel bar is capital T. Equate these two. Okay, so what is force? Force is equal to stress into area. Okay, how will going to find out force? Force is equal to stress into area. So what is stress in concrete? 0.36 FCK. Okay, 0.36 FCK. It is a stress into area of concrete is, now see, area of, this is the concrete now, this is steel pole. So only this area of concrete is B into XU. This is neutral axis depth, no? So what is the area of this concrete? B into XU. Okay, so force, total force is equal to what? Stress into area. So stress in concrete is 0.36 FCK and area of concrete is B into XU. This is total compressive force in concrete. Then what is total tensile force in steel? Again, total force is equal to stress into area. So what is stress in steel? 0.87 Fy will be the stress. 0.87 Fy, it is stress. And what is the area of steel? Area of steel will be AST. Okay, so total force C is equal to total tensile force T. So force is equal to stress into area of concrete, and total tensile force is equal to stress in steel into area of steel. Okay, so substitute the values. So 0.36 FCK is 20, B is 300 into XU. Okay, so we know that for a limiting condition, XU is equal to XU limit or XU max. Okay, XU is equal to XU limit or XU max, and we know that XU max upon D or XU by D is same. So XU max upon D is equal to 0.48. Okay, so therefore XU max is equal to D into 0.48. XU max is equal to D into 0.48, that is 0.48 into D, effective depth 500. So we'll get XU max is equal to 240. So for limiting condition, XU max is equal to XU or XU is equal to XU max. So XU is also 240 mm. So 0.36 FCK B, that is 300 into XU will be 240 mm. So that is equal to 0.87 Fy, that is 415 into AST. We have to find out this AST, keep as it is AST. So therefore AST is equal to what? This term divided by 0.87 Fy. That is AST is equal to 0.36 into 20 into 300 into 240 divided by 0.87 into 415 will give AST. So therefore total area of steel provided or required will be 1435.8 mm square. So this much total area of steel will be there. Then only you can say that this is the maximum steel provided. Condition is maximum steel will be how much? 1435.81 mm square. So this is the important problem. Okay, so please note that I have written here important. Solve this problem and even you can solve the previous problems what we have solved in the sessions. Okay, so whatever the problems till now we have solved, all these problems will be considered as type 1 problems. Okay, type 1 problem. So try to understand what is type 1 problems, what you need to find out here. So here size of the beam will be given. Okay, all grades of concrete and grades of steel will be given, and load, sometimes load will be given. Okay, so we need to find span will be given, so we need to find out this W, total UDL, or we need to find out moment of resistance. Okay, moment of resistance you need to find out in the first type of problem. Okay, so please solve all these problems, all these 6 problems. Okay, and practice these problems. If you any doubt, okay, so you feel free to ask me. Okay, so now let us move on to the next. Okay, so these whatever the problems you have solved, all these are the type 1 problems. Now let us see what type 2 problems. Okay, in exam also try to understand, as soon as if you get the problem, first see whether it is a type 1 problem or it is a type 2 problems. Then depending upon that you have to use the procedure. Okay, so let us see what is type 2 problems. Again we'll see what is the given things in this type 2 problems and what you need to find out, that we're going to see. So in type 2 problems the given data are factored or ultimate moment. See, so here directly factored moment mu or mu limit will be given. Okay, factored or ultimate moment mu or m will be given. So in the previous case we have calculated this depending upon under reinforced or over reinforced, we have calculated mu or mu limit. But in this type 2 problems directly they will going to give either mu or working m, that is m. So if mu is given, divided by 1.5 you will get m. So if m is given, multiply 1.5 will get mu. So mu or mu limit will be given or m will be given. Or instead of this mu or m, what they're going to give? They're going to give the total load. Total load plus span will be given. Okay, total load on the beam, like whatever W we have calculated in the previous section. So total load means small w. Okay, UDL will be given plus span with type of support, that is simply support or cantilever they will going to give. Then we need to calculate the maximum bending moment. So depending upon this, then size of the beam will be given, grade of steel and concrete will be given. So only change is here directly we are going to get the moment of resistance mu or mu limit will be given. Okay, or total load plus span will be given. You can calculate mu or mu limit. Then what is required here? What you need to find out here? We need to find out area of steel. So AST will not be given, so that you have to find out. So type 2 problems mainly, okay, what? Finding out the area of steel. M or mu will be given. We need to find out AST. Okay, so then what are the steps to be followed? So the steps for finding out this area of steel will be like this. The first step, okay, if load is given small w, total UDL small w, and effective span L is given. Okay, directly instead of this m or mu, what they will going to do? They will going to give load and span, effective span. Okay, then we need to find out maximum bending moment. Okay, maximum bending moment m is equal to WL square by 8. So in the previous case we have seen that what is the maximum bending moment? M is equal to WL square by 8. This is for simply supported beam carrying UDL. So read the problem. If it is a simply supported beam subjected to UDL, then what is maximum bending moment? WL square by 8. So here W will be given in the problem. L will be given in the problem, so you can calculate the M. Okay, that is maximum bending moment M is equal to WL square by 8. So if it is simply supported beam carrying UDL, or maximum bending moment M is equal to W small w L square divided by 2. Okay, WL square by 2. This is for cantilever beam with UDL. So two beams will be there right now. One is simply supported beam with UDL. If it is simply supported beam with UDL, you have to calculate M is equal to WL square by 8. If it is a cantilever beam with UDL, okay, cantilever beam with UDL, so it is M is equal to WL square by 2. So for simply supported, it is divided by 8. For cantilever, it is divided by 2. So WL square by 8 or WL square by 2 for cantilever with UDL. So this is first step. So from this, we're going to get M. So if it is simply supported beam, we'll calculate this M. Or if it is a cantilever beam, we're going to calculate this M. So M indicates working moment. Okay, M indicates working moment. So now I want ultimate moment. MU I want. So MU is equal to whatever M you will going to get, multiply 1.5. So ultimate moment MU is equal to M into 1.5. M into 1.5. So finally we required this MU. So if directly they will going to give this MU, or they will going to give load or effective span. Load and effective span, if it is given, calculate MU like this. Or if directly MU is given, okay, so this step will be not considered. Directly you can go for this step. So then after getting this MU, so what is the second step? Now equate this ultimate moment, equate whatever MU will going to get, that is equal to MU limiting condition. So whatever MU will going to calculate, that will be equated to MU limit. Okay, then so formula what we are going to use here is MU is equal to, this MU is equal to 0.87 Fy AST D into bracket 1 minus AST upon BD into Fy upon FCK. Okay, so we need to find out this AST. So after finding out this MU, equate this MU is equal to MU limit. Equate MU is equal to MU limit and use the formula this. So here only unknown is AST, but after substituting all these values except AST, all the things are known here except this AST, everything will be substituted, and after substitution we are going to get this is quadratic equation. Okay, there will be a quadratic equation for this. This is a quadratic equation. Then solve this quadratic equation, we are going to get the AST. Okay, after solving quadratic equation, we will going to get the area of steel required. So remember two steps. Okay, if load and effective span is given, see the condition whether it is simply supported beam or cantilever beam. Depending upon that, we can calculate M. So multiply this M with 1.5, we are going to get the ultimate moment of resistance, that is MU. Then equate this MU is equal to MU limit and use the formula MU is equal to this. This formula you will going to get as a quadratic equation. Solve the quadratic equation and there will be two answers. Two solutions will be there. One in terms of positive and one in terms of negative. So there will not be any negative reinforcement. Okay, only positive values you will going to consider as the area of steel. So this is the second type of problem and the steps to be followed. So in the next session we will going to consider problems on this type 2. Okay, so hope you understood this procedure and the previous problem what you have solved. So in the next class we come up with type 2 problems, but before that you go to this these steps and be ready for the type 2 problems. Okay, thank you very much for attending this session. So please solve all the problems, that is type 1 problems. Okay, so if any doubt, please ask me. Okay, so thank you very much for attending this session. Thank you.